Please appreciate this presentation has been prepared with all sincerity and to the best of knowledge of students, teachers, and volunteers. We welcome words of encouragement and also suggestions for improvement. For use in academics or any kind of exams, please verify and correlate with your course books. For becoming an associate and or for sending contributions in different subjects, including storytelling, please get in touch with your brief profile at baskinjoy@gmail.com. So we know that everything is made up of atoms. These two things we have over here are atoms, and atoms have a nucleus. They have a nucleus. So this is these two. You have the nucleus right here, and around this nucleus, all of these atoms have different electrons. So you can have some electrons here, some here, like this. This isn't actually how um you would see electrons depicted, but this is just a diagram, just to understand this concept of electricity that we're going to be talking about. So you have these atoms with electrons around the nucleus, and there's some type of atoms have a nucleus where the electrons stick to the nucleus really good. So you have atoms of materials like rubber, uh, materials like plastic. That's materials like plastic. These type of materials are made up of atoms where the electrons are really good at sticking to the nucleus, and uh, we call these type of atoms insulators. And in other atoms, you have nucleuses. You have nuclei where the atom is where the nucleus isn't that as good at uh, holding electrons. So the electrons are more free to move around and stuff like that. So you have so these atoms make up materials like metals and stuff like that. And so these type of atoms they make up metals, and they have electrons which can move around more freely than these type of atoms, and we call these type of atoms conductors. So these are conductors which have electrons which can move around more freely, and these are insulators where the electron is more like pulled into the nucleus. And so what electricity basically boils down to is the movement of electrons. So electricity is just basically how it's just electrons moving from one place to another. So you have an electron here, it goes from here to here. So we see that electricity is flowing from here to here. And so you can imagine some type of material, and this material is made up of atoms. So take this material for example. So this is going to have some atoms in it. Uh, so these are some atoms, and so all of these atoms have different nucleus. I mean, have all of these atoms have different electrons. So these tiny little dots are electrons. And so if these atoms are insulators, we talked about before how insulators, atoms that make up insulators, the electrons over there are pulled towards the nucleus. The electrons are pulled towards the nucleus. So you can see that the electrons, it's not going to be easy for the electrons to move around. And so because the electrons are going to stick to the nucleus, you won't see any electrons going from this end to that end or from this end to that end. And so you won't see, it's going to be basically hard to push electrons from one side to the other side because all of the nucleus, all of the nuclei, they're holding on to the electrons really well. And so it's going to be really hard for electricity to flow through this. And so, as we talked about before, this type of material where it's going to be hard for electricity to flow through, we're going to call that insulators. And so, now the other type of material we talked about was conductors. And so, in conductors, again, you have atoms which make which make up the conductor, and these atoms have little electrons around them. These dots which I'm making right now are electrons. And so in conductors we talked about how these type of atoms, it's the nuclei, they don't really hold on to the electrons that well, so the electrons are more free to move around. They don't have as much resistance, And so you can imagine that it would be easier for electrons to move from one end to the other end, or from this end to this end. So it's going to be easy for electricity to flow through them. So we call these materials again conductors, right? And so that's basically how some materials make it easy for electricity to flow through them, and some materials make it hard for electricity to flow through them. But electricity isn't just electrons, random electrons moving around, you see. So if I take this right here, so if you have this material over here and electrons, and so these are all electrons, if they're just moving around like this, like that, just randomly, that isn't electricity, because when we want electricity, we want electrons to be flowing in one direction. So if they're flowing like this, we want all of these electrons to flow in this. We want all of them flowing in that same direction. And so when they're flowing in the same direction, we're gonna call it. That's when we're gonna call it that electricity is flowing through here. And so now the question comes that why would electrons want to move in one specific direction? So, we talked about how there's going to be electrons here. I'm not going to draw the nuclei because we know that they exist. I'm just drawing the electrons right now. So just pretend that there's also nuclei around here. But what I've drawn is just the electrons that this material is made up of. So we have all of these electrons inside a material. And so, if electrons were free and stuff, they would just move around wherever they wanted to. So the question is, why would electrons want to move in one direction only? And so they would want to move in uh, one direction when there is a potential difference between two ends of a conductor. So they would want to move from one end. So let's say there's electrons over here. These are all electrons. They would want to move from this end of the conductor to that end of the conductor only when there is a potential difference between these two ends. So you need a potential difference between the two ends of the conductor. Okay, so now what is this potential difference that makes electrons go from one end to the other end? So you can think of a potential difference like gravity. So if you take a ball to a really high height, like there's a ball right here, you um, you're on top of a building, you're holding, you're standing right here like this, you're holding this ball with your really big hand. And so gravity, of course, is gonna make this ball move to the ground. It's not just gonna float around in the air. And so when you're taking this ball to the top of the building, what you're doing is that you're giving it gravitational potential energy. Basically, you're giving it a lot of potential energy. And so when this ball is up high up here, it has potential energy, and gravity pushes it down, gives it kinetic energy, and it reaches the ground right here. And so that basically, what this gravity did was that when basically what gravity did is that when you brought the ball up, you gave it potential energy, and because of that potential energy it had, uh, it wants to have zero potential energy at the end of the day. Everything wants to have minimize the amount of energy it has, and so it moves to the ground where it will have less potential energy. And so uh, basically, just like that, you can also think of uh, potential difference like giving one side of the electrons, the side over here, you give this side a lot of potential energy, give this side a lot of potential energy, and this side is going to have low potential energy, low potential energy. And so, like a ball, when it had high potential energy, it wanted to go to a place where there was low potential energy, which was the ground. Electrons over here, they have high potential energy, and they want to go to a place where there's low potential energy, and that's the other side of the of the material. And so giving a conductor a potential difference between two ends basically means that this end over here has a higher potential energy than this end over here. And this potential energy makes the electrons flow from that side to this side. And so when you create a potential difference between, uh, so here's a quick recap now. Electrons start moving in a material when there's a lot of when there's a potential difference where the objects are. They're going to move from high potential energy to low potential energy. And so, uh, how are you going to give this material potential energy? So where is this high potential energy and low potential energy going to come from? How do we give it to them? So, like we were talking about that case of the ball, the gravity is giving it. Gravity gives this ball a high potential energy over here. High potential energy, energy because of gravity. And so that's why the ball had high potential energy. So now why do electrons over here have high potential energy? Okay, so basically, giving one sided giving a material a potential difference, giving a material a high potential energy is basically the job of things like a battery. You have a battery here like this battery, or like a generator, stuff like these. These things give using like complicated mechanics and all that stuff. Batteries and generators, they give materials high potential energy on one end and a low potential energy on the other end. And so by doing that, then it allows electrons to move and electricity to be conducted. And so uh, now we're going to talk about what electric circuits are. And so basically, what you have over here is an electric circuit. Yeah, this is an electric circuit. So what this is basically a closed loop for electrons to keep on flowing through. So this is like what you see here in the middle. This is a battery or a generator, whatever, something that's giving uh, this material potential difference. So like right now we were talking about just like rectangles and like bars of materials. So you go from this end to that end. It's not on a closed loop. When electrons go from this end to this end, there's no way for it to go back here. But in electric circuits, electrons, they're going to start from here. This is where they have high potential energy. High potential energy because of the battery. This place has high potential energy. Electrons are going to move from here. They're going to keep moving along this wire, and they're going to end up back here where there is low potential energy. And then the battery is going to push these electrons back here to the high potential energy, and they're going to go back and around. And this basically creates a closed loop where the electrons are going to keep on flowing in this material. And so this is what basically a circuit is. You're going to have a constant flow of electricity. And so the electrons are going to come out of the negative terminal, and they're going to enter the positive terminal. So you have, let me make this a little clearer. So you have this battery here. Whenever you've seen batteries, they have this minus here, and there's this plus here. And so basically the electrons are going to get pushed out of this negative terminal, and they're going to come into the positive terminal, and this is going to keep on going in loops. And so in basically a closed circuit, where you can in these electric circuits, what you can do is that uh, wait, let me draw this circuit again. So you have this circuit, and the electrons are moving around inside it like this. And so using the circuit, you can like put different things such as you can put a torch here, not a torch, I mean like a lamp here, right? So imagine this is a lamp. Sorry, this is a lamp. And so when the electrons are going to move through this, they're going to power the lamp, and that's what's going to cause the lamp to glow. Because the electrons are moving through it, it's going to push some stuff around. It's going to create energy inside the lamp, and it's going to basically allow the lamp to glow, and then we'll get some light. So anything that needs power, you put it right in the middle of the electron's path, and then the electrons are going to give it some energy. It had that high potential energy here. It's going to give it some energy, whatever thing you decide to put in the circuit. It can be a lamp, it can be a shaver, it can be a torch, it can be a motor, anything like that, and it's going to give it power, and it's going to start working the thing that you want to work. And so, to understand how all of this is working mathematically, we need to understand some formulas, and we're going to have to define some terms. And the first term is current. And so, what current is it tells us how much charge is moving through a specific region in some amount of time. So, what current tells us is how much current is moving in some time. Not how much current, I mean how much charge is moving in some time. And so this is what this is basically charge divided by time. And in science, the the charge has the variable q, and time has the variable t. And so that's what the formula for current is: q upon t, charge upon time. And so we know that electrons are what the charges are that are moving inside the current, and that is so it's just the electrons that are moving around. And so we can say that if there are some amount of electrons that are moving in a specific amount of time, you can just basically multiply the amount of electrons that are moving into the amount of charge that one electron has. So what you do is just the charge on one electron into the number of electrons, whoops, divided by time. I'll go to the next page here. So what that means is that you can have n, which is the number of electrons, times the charge on one electron. You can call that q, divided by t. And so that also gives us current. Actually, I'll name this something else. So you have the number of electrons into the charge on one electron divided by time, which is the same thing as the total amount of charge upon time, and that's current. So these two things is just telling us the same thing: how much charge is moving in a specific amount of time. What Q is that the total amount of charge. What N into E is that the number of electrons times the charge of one electron, which gives us the total charge. And so this current, we get this in uh, charge. So what this is charge per time. So that means this is charge per second, and the units of charge is coulombs. So you have coulomb per second and this is also known as an ampere. So the unit of current is coulomb per second, or charge per second, or ampere. All of these mean the same exact thing. And now the next term is voltage. So voltage is basically the potential difference we were talking about. So voltage is uh, potential the potential difference between this end and that end. It's basically it just gives you the number of that potential difference. And so this voltage, this potential difference, it's measured in volts. That's the unit, volts. And so if you want to find out how much current, uh, so wait, let me just make another circuit. So you have this circuit. Say you know that there's this battery is giving this whole circuit some potential difference. So that potential difference is V. And uh, if you want to find out how much current is going to flow in this circuit because of this potential difference V, we get that current using this formula. V equals I into R. So V is the potential difference, the voltage, potential difference, or voltage. I is the current, and R is the resistance. And so this is a new term, resistance. What is resistance? So it just resistance basically means, whoops. Resistance basically means how much a current, how much the circuit is stopping the current from flowing. So we talked about conductors and insulators before. The conductors don't really stop the electrons from flowing, so its resistance is low. We talked about how in conductors the electrons they can move around more freely, and so the conductors don't really stop the flow of electrons. So it doesn't stop electricity from moving. It doesn't want to stop electricity from moving that much, and so it's going to have a low resistance. So it's more free to move. That's conductors. They have a low resistance. And insulators, talk about how the nuclei they hold on to the electrons better, and so it's going to be harder for the electrons to move around. It's going to be harder for electricity to flow through, and so these are going to have a high resistance because they don't want electricity to flow through them. And so that's basically the whole idea of resistance. It's just how much a specific material, how much a conductor or an insulator wants to stop electricity from flowing through it. And the units of resistance is ohms. And you also sometimes see it as, oops, that's wrong. Uh, Also sometimes see it like this. That's ohms. And so with this formula, V equals I into R. If you know the so say you have what the voltage, what the potential difference is, and what the resistance is, and you want to find out how much current the circuit will have. So what you do is you basically rearrange the terms, and you just get V upon R equals I. You divide the potential difference by the resistance of that material, and you get how much current is going to flow through that circuit. And the same way, you can divide V by I, and you get what the resistance will be. And so basically using simple algebra, you can find out various different terms in this formula. And so this class, we just talked about kind of an introduction of what electricity is about. In the next class, we'll talk about some more fancy things which are related to electricity.